Understanding terminology is foundational to implementing operator-driven reliability and TPM. Autonomous maintenance refers to activities performed by equipment operators, such as cleaning, inspection, lubrication, and minor adjustments, without relying on maintenance staff. This builds ownership and early failure detection. OEE, overall equipment effectiveness, measures the percentage of manufacturing time that is truly productive. It combines availability, performance, and quality to assess asset efficiency. TEEP, total effective equipment performance, includes OEE plus the impact of scheduling utilization, capturing full potential. The visual workplace is a system where tools, parts, and information are clearly labeled and organized for immediate recognition. This reduces search time and errors. Gemba means the real place, where value is created, usually the shop floor. Kaizen is continuous improvement, and Kanban is a signal system for replenishment, both integral to lean practices. Muda, Mura, Muri are the three types of waste. Muda, waste of resources, Mura, unevenness, and Muri, overburden. These must be minimized for efficient operations. Poka-Yoke is a Japanese term for mistake-proofing, designing systems or tools to prevent human error or ensure detection before damage occurs. Together, these terms define the language of reliability-driven operations and are essential for aligning people, process, and performance in maintenance and operations. Operations plays a critical role in maintaining equipment reliability because operators are closest to the assets and interact with them daily. Their proximity allows them to notice early signs of abnormal behavior, such as unusual noise, vibration, smell, or temperature, long before these develop into functional failures. By shifting from a passive to a proactive role, operators become the first line of defense in the reliability process. Instead of simply reporting issues, they take ownership of routine care tasks like cleaning, inspecting, tightening, and basic lubrication. This lightens the load on maintenance teams and enables faster response times. ODR, operator-driven reliability, creates a culture of ownership where each operator feels responsible not only for running the machine, but also for keeping it in good condition. This ownership mindset helps bridge the historical gap between operations and maintenance, fostering collaboration rather than blame. Training is vital in this transition. Operators need to understand what to look for and how to act safely and correctly. Over time, their involvement leads to fewer breakdowns, better performance data, improved morale, and a shift in organizational mindset from reactive to proactive maintenance. Total Productive Maintenance, TPM, is a proactive maintenance philosophy that aims to maximize equipment effectiveness by involving everyone in the organization, from top management to floor operators. Its goal is not just to fix machines, but to prevent them from failing in the first place. TPM originated in Japan, notably from Nippon Denso, a Toyota Group company. Unlike traditional maintenance, which is often reactive and limited to maintenance technicians, TPM is a holistic, team-based strategy that integrates maintenance into daily operations. It shifts the focus from breakdown response to loss elimination, targeting equipment-related losses like unplanned downtime, speed reduction, and defects. TPM is structured around measurable goals like 0 breakdowns, 0 defects, and 0 accidents, reflecting both technical and cultural improvement. Unlike conventional approaches where operators only run equipment, TPM encourages them to care for it as well. This active operator involvement leads to early detection of problems, cleaner and safer workplaces, and reduced maintenance workload. Ultimately, TPM is not just a set of tools. It's a cultural shift that aligns equipment reliability with continuous improvement, workforce development, and operational excellence. The objectives of Total Productive Maintenance, TPM, are centered around achieving maximum equipment effectiveness while simultaneously developing a workforce that is engaged, skilled, and accountable. One of the primary goals is to increase asset uptime by preventing failures before they occur through proactive and preventive practices. TPM also seeks to reduce maintenance costs by minimizing unplanned repairs, emergency interventions, and the reliance on external vendors. At the same time, It fosters a safer working environment by ensuring equipment is clean, well maintained, and free from hidden defects that could lead to accidents. An important cultural benefit of TPM is the creation of a high morale, ownership driven workforce. Operators and maintenance personnel take pride in their equipment, leading to better care, faster response to issues, and fewer handoffs or misunderstandings. By improving reliability and reducing defects, TPM enhances product quality and customer satisfaction. Downtime is minimized, output is stabilized, and rework is reduced, each contributing to a smoother production flow. Another key benefit is employee empowerment. TPM builds skills through hands-on training, encourages participation in problem solving, and gives operators real influence over asset health. The result is a resilient, performance-focused culture that directly supports business goals. The TPM framework is built on 8 foundational pillars, each designed to address a specific area of equipment effectiveness and organizational engagement. 1. Autonomous maintenance empowers operators to take responsibility for basic maintenance tasks such as cleaning, lubrication, and inspections. This fosters early detection and reduces dependency on maintenance teams for routine issues. 2. Focused improvement, Kaizen, targets chronic losses and inefficiencies through small, team-based problem-solving efforts. It emphasizes incremental gains over time, using data to eliminate root causes of performance loss. 3. Planned maintenance involves scheduling maintenance tasks based on equipment condition or usage data rather than reacting to breakdowns. This improves uptime and resource allocation. 4. Quality maintenance integrates defect prevention directly into maintenance activities. It identifies conditions that lead to quality issues and addresses them through root cause elimination and equipment precision. 5. Training and development ensures that all employees, from operators to managers, have the skills needed to maintain, analyze, and improve their processes and assets. It builds a cross-functional, knowledgeable workforce. 6. Early equipment management, EM, brings TPM principles into the design and installation phases of new equipment. By involving operators and maintainers early, it improves maintainability, accessibility, and reliability. 7. Office TPM administrative support applies TPM principles to support departments, streamlining workflows, reducing clerical errors, and improving communication between functions. 8. Safety, health, and environment. TEEP ensures that all improvement efforts prioritize a safe, sustainable workplace. This pillar addresses risk reduction, compliance, and environmental stewardship alongside productivity. Together, these pillars create a comprehensive approach to operational excellence that reaches far beyond the maintenance department. Implementing TPM requires a structured, step-by-step approach that begins with strong leadership commitment. Without clear support from management, TPM efforts often stall or revert to traditional reactive practices. Leadership sets the vision, allocates resources, and reinforces accountability throughout the organization. The next step is to establish cross-functional TPM teams, including operators, maintenance personnel, engineers, and supervisors. These teams are responsible for piloting TPM practices, collecting data, and leading continuous improvement efforts within their respective areas. Training and awareness are essential during early implementation. Employees need to understand not only the tools of TPM, but also the cultural shift it demands, where ownership, teamwork, and reliability are core values. This includes educating team members on equipment basics, loss identification, root cause analysis, and visual workplace tools. As teams gain experience, organizations begin to implement autonomous maintenance activities, starting with cleaning and inspecting equipment, establishing visual controls, and tagging defects. These early wins create momentum and build operator confidence. Kaizen activities follow, focusing on eliminating chronic issues through collaborative problem solving. TPM principles are then extended to other pillars, such as planned maintenance and quality maintenance, each supported by standard work procedures and performance metrics. Throughout the implementation, it's critical to document progress, celebrate milestones, and sustain engagement through regular reviews and coaching. Successful TPM is not a quick fix. It's a cultural transformation that requires time, consistency, and broad participation across all levels. The 5S methodology forms the foundation for workplace organization and is often the first step in implementing TPM. It creates a clean, safe, and efficient environment that enables reliable equipment operation and easy detection of abnormalities. 1. Sort. Eliminate unnecessary items from the workspace. Only tools, materials, and parts that are needed for current operations should remain. This reduces clutter and creates room for efficient workflows. 2. Set in order. Arrange items so they are easy to find, access, and return. Labeling shelves, shadow boards for tools, and color-coded markings are common practices. This step minimizes time wasted searching for items. 3. Shine, say so. Clean the work area and equipment thoroughly. Cleaning isn't just for appearance, it helps detect leaks, wear, or other early signs of equipment failure. It reinforces ownership and pride in the workspace. 4. Standardize. Create consistent procedures and schedules for maintaining the first 3 S's. Visual controls and standard checklists help sustain order and ensure consistency across teams and shifts. 5. Sustain Shitsuki. Embed 5S into the culture by encouraging discipline, regular audits, and accountability. This step is the most difficult but most critical. Without it, the system erodes over time. Some organizations also add a 6th S, safety, to emphasize risk reduction and compliance as integral parts of workplace organization. 5S supports TPM by stabilizing the environment, reducing waste, and empowering operators to take ownership of their area and equipment. It's a visual and cultural framework for continuous improvement. Overall equipment effectiveness, OEE, is a key performance metric in TPM that quantifies how effectively a piece of equipment is used. It combines 3 critical factors, availability, performance, and quality, into a single percentage that reflects the portion of time equipment is truly productive. Availability measures the percentage of scheduled time that the equipment is actually running. It accounts for both planned and unplanned downtime. Performance reflects whether the equipment is operating at its designed speed. Losses here include slow cycles and minor stoppages. Quality indicates the proportion of output that meets specifications without rework or defects. OEE is calculated by multiplying these 3 components. OEE equals availability, times performance, and quality. In practice, if a machine is running 90% of the time it's scheduled, at 95% of its optimal speed, and producing 98% defect-free parts, its OEE would be 0.90, 0.95 equals 83.7%. Not TEEP, total effective equipment performance, goes a step further. It multiplies OEE by utilization, the percentage of total calendar time the equipment is scheduled to run. TEEP reveals the full potential of equipment if it were available 24/7. Understanding and tracking OEE helps organizations identify where performance losses are occurring and prioritize improvements. It's a practical, data-driven way to monitor TPM success and align equipment performance with business goals. Measuring performance in an operator-driven reliability and TPM environment requires tracking metrics that reflect both equipment condition and operator engagement. One core measure is downtime, which can be broken down into categories like operational delays, maintenance interventions, and total stoppages. Monitoring downtime trends helps identify systemic issues and justify improvement initiatives. Another key indicator is OEE, overall equipment effectiveness. OEE tracks how effectively equipment is running by combining availability, performance, and quality into a single metric. Tracking OEE over time reveals whether TPM initiatives are reducing losses and improving reliability. 5S audits are also common, using checklists to evaluate cleanliness, organization, labeling, and safety in the work area. These audits reinforce discipline and ensure that standards are being followed consistently. Operator metrics, such as the percentage of trained or certified operators, show how well the workforce is prepared to support autonomous maintenance tasks. High certification levels typically correlate with fewer minor failures and better early detection of issues. Finally, delivery schedule adherence for maintenance tasks indicates how well planned activities are executed without disruption. If maintenance is consistently completed on time, It reflects well on planning, thus scheduling, and operator readiness. Together, these performance measures provide a comprehensive view of how TPM and operator involvement are impacting asset reliability, workforce effectiveness, and continuous improvement.